Hey, calculus wizards! Whoo, man, it's hot out tonight. If I could make myself appear in Alaska right now, I would. Okay, so properties of logarithms, and this also applies, of course, to natural logs. You may or may not remember. So, natural log of 1 is 0. And this whole log, remember, is the inverse operation of exponentials. And of course it tells me what base it is here at the bottom. So remember, even though I don't write it, this is a log base of e. That's why we use natural log. And if I were to put this back into exponential form, remember it would be e to the 0 as switch equals 1. Okay, hopefully I'm talking loud enough in this one. Next log property that hopefully you remember is that I can split. So when I have a product, I can split them, and so I can do the sum of their logs. Notice I'm using natural log base. We'll use natural logs a lot. We probably won't use regular logs as much. We tend to use natural logs a lot. Sorry that this ends up being really kind of creepy lettering. This stylus is not a lot of fun to work with. Okay, and then the third one is when you're doing quotient rule. Of course, you can split, and hopefully you're saying right now to yourself, oh yes, 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 I remember. It turns into subtraction. And you were right. And then the last one, of course, is the power rule. And hopefully that you remember on this one that if I have a log, that's an n. Grr. Sometimes I have to erase these a lot of times when I'm not actually doing the recording. That you can bring the power down in front, and so I get n times natural log of a. Okay, I'm going to shift this over so I have lots of room, so magic's going to happen, all that's going to disapparate. Okay, so now on the exponential side, and of course I might be using a base of e. We will use base of e a lot this year. And so e to the x, okay. So if I have the same base raised, oops, I didn't mean to do that, raised to 2 different powers, of course it turns into the a plus b. Easiest way to convince yourself of this is if you go over here and you do a simple little exercise like same base. Of course that turns into x to the 5th because I added those powers. Second one is if I'm doing division, and hopefully you're saying to yourself, oh, I know this one. I subtract the powers. Again, easy example would be something like x to the 12th over x to the 8th. And of course you can subtract and get x to the 4th. And the third one is natural log of e to the x is just x. And of course that comes from dropping down that power. So remember just a second ago we said we could move that down in front. And if you remember, natural log of e is just 1. So this right here equals 1. And so I get x. That's where it comes from. And then last but not least, if we do e to the power of natural log of x, that's also just x. Now here's how that magic happens. If you remember when you were doing log bases and you had something like 5 to the log base 5 of 7, if the log base and the exponential base matched, these are inverse operations of each other, so essentially they undo each other, and then I just get left with that. And so same issue here. Remember, this is a natural log base is e, and so those match, and so these cancel out, which is how I get just x. Okay, I'm going to turn the page here in a second. Okay, so here are all the formulas that hopefully you remember from geometry. Remember, cylinder and cone both have pi r squared h, but the cone is 1/3 of it. Sphere, I just remember that the cubes are in the volume, and of course area has the squared, so r cubed and 4/3. And the rectangular prism, length times width times height. You'll use these throughout the year, so these are just a reminder. Okay, see you in the next video, kids!